What's up, Honors Algebra 2? We're going to go through some examples that deal with factoring sums and differences of cubes. To start off, how about we simplify the expressions in numbers 1 and 2? Simplify, of course, meaning just carry out all of the multiplication that you can spy with your little eye, watch the exponent rules, and combine like terms. I will pause while you work that out. Catch up to you in a sec. Okay, hopefully by now we have the same two expressions as our answers, and I brought in some soap because, I think this might get a little dirty. But looking at number 1, we have combined all the like terms, many canceled out, and we get an answer of a cubed plus b cubed. A cubed thing plus a cubed thing, the sum of cubes. Looking at number 2, when we work it all out, multiply, combine like terms, we get an answer in the form a cubed minus b cubed, the difference of two perfect cubes. So naturally, this now leads us to understand moving in the top-down direction. We are simplifying an expression, but if we take the starting expression as a formula, we would be able to now break down the sums of cubes and the difference of cubes and write them as a product, which is factoring. So these two expressions will become the formulas that lead us to our big master list so far of factoring techniques. So the first rule of factoring, always look for a GCF. Everything that you do after that depends on how many terms you have, so I hope we can count. When you have two terms, all you've got to look for, are they the difference of squares? Break it on down to conjugate pairs. If it's the sum of squares, we cannot factor that using real numbers. You may call that prime. I don't need you to factor with i's. But now that we have more knowledge about cubes, the difference of cubes will always factor out accordingly. A minus b, a squared plus ab plus b squared, and then a cubed plus b cubed. We see the formula down here. So you do see some soap in the video, you see a little soap icon, and there is a little mnemonic device I can give you to help you remember the differences between these two formulas. They're really similar, they have the same terms in them, they both have an a b, an a squared, a single product, not a double product, and a b squared. What is true about the signs, ready? The first sign is always the same as the sign in the expression. The middle sign is always the opposite of the sign in the expression. And the third sign is always positive. So you can use your soap to help you figure out the sums and differences of cubes. All right. Please just take a moment and make sure we see the distinction here. Stop the insanity. Don't distribute functions. The sum of two cubes is not the sum cubed, and the difference of two cubes is not the difference cubed, and we can try that out with numbers. If I take 2 plus 3 cubed, I'm going to compare it to 2 cubed plus 3 cubed, and we're going to get two different values. 2 plus 3 cubed, well, is really 5 cubed, and that is the value 125. When we take each cube separately, 2 cubed is 8, 3 cubed is 27, and adding them up, we get a 35. Clearly two different numbers, leading us again to the old standby, don't distribute functions. So I'm going to factor some cubes here with you and ask you to complete a few on your own. Let's try number 3. First, we would look for a GCF. I do not see a GCF, so the next thing I do is count. I have two terms, and it turns out the first term, of course, is the cube of x, and the second term is the cube of 216. We do indeed have the difference of two cubes. So in the cube formula, a cubed minus b cubed, I'll just write it for reference. I will not do that every time. It does help you memorize it though. We've just got to ascertain the values of a, b, the square, the single product, and the square. Well, a and b are pretty self-explanatory. A is what you cube to get the first term. B is what you cube to get the second term. Great. Now we just need a square, a single product, and a square. So the square of a, well, that takes x squared, multiply x with itself. The single product will multiply x with 6. And for the final, we'll take the value of 6, square it, we'll get 36. Perfect. So these are the 5 terms that I will use in my formula. And obviously, as you get a little bit better and better at these, you tend not to write as much. You just roll it off and do it. All right, but again, just check that middle term is a single product. So this is not a perfect square trinomial. It does not factor further. That is our final factored form. Okay, let's try out number 4. I have an expression here. I look for a GCF. I do not find one. I count the terms. 2. All right. Let's see if they are fitting the mold of squares or cubes. All right, c to the 6th. Well, that really could be a cube. If we think of it as a c squared cubed. And of course, 27, we all know that number. That is the cube of the number 3. Perfect. We have the sum of 2 perfect cubes. Once again, just for reference, I will jot down the formula. Like I said, the more you write it, the more you remember it. And, well, let's see what we're using in the formula. In the place of a, I will insert c squared. In the place of b, I will use a value of 3. And that makes my a squared value c squared times itself. That makes my single product, whoopsie, 3c squared, and that makes my last square a 9. Alrighty, let's use these, put them in their proper places. And this should be our final factored form. Once again, this middle term is a single product. We do not have a perfect square trinomial. That does not break down further. All right, let's just try a few more in this video. I've got to leave you a few to try on your own. If we scooch ahead to number 6, that's got to have some fun stuff to it. All right, let's look. We've got to look for a GCF. That's the first rule. So the GCF in this case, well, both terms have an 8. Both terms contain at least 2 powers of n. All right, let's yank that out first. That's going to leave us n cubed minus 8. All right, we did a great first thing there, but let's make sure we can call this done. Uh-oh, right here, I've got the difference of 2 perfect cubes. So we'll keep that GCF alive and well, and let's set up a little template for a binomial and a trinomial. I'm going to try to do this one with a little less writing. Let me fill the signs in first. Let's use some soap. All right, we've got the same sign going here, opposite here, always positive here. All right, let's figure out what the first binomial contains. Well, that's pretty much always going to be what we cubed to get each of these. So what did we cube to make n cubed? N. And what did we cube to make 8? 2. So there's our first binomial. Looks pretty good. Now we need a square, a single product, and a square. So let's square the n. Let's make a single product, and let's square the 2. And once you get comfortable, it can be that easy. And that's as far as we can take it. Once again, this is a single product, not a double product. We cannot break that down any further. Okay, I believe the last one I'd like to try live with you guys is number 8, because it has a fraction, and I'm sure that's a little scary. Well, looking for a GCF, I cannot possibly see anything within a 512, a 27, and a 343. There's no variables in common, but hopefully by now these numbers are very familiar to you, and everything I see is a cube. I might do a little extra work here just to determine what got cubed to make each term, and then I'll jump right into the formula. All right, let's think of 512. I know that is the cube of 8. Let's think of what we cubed to make x to the 6th. That would be an x squared. And to make y cubed, that would only need a y. All right, moving on to the fraction, I'll take the numerator and the denominator separately. To make 27, I would cube 3. And to make 343, I would cube 7. All right, so these are the building blocks of my formula. And now let's make a little template for our binomial, which I know will just be these two terms with the same sign, and a trinomial containing a square, single product, and a square. So let's, same, opposite, always positive, and let's see what we can fill in. All right, we know we'll have 8x squared y right here, and 3/7 here. Beautiful. All right, I'm going to have a square here, so take 8x squared y. Think about multiplying it with itself. We get 64x to the 4th y squared. And now we've got to muscle through the single product. We just have to multiply 8x squared y with 3/7. Well, if we think about that as being over 1, I will multiply the numerators and multiply the denominators. Oh, that wasn't so bad. And lastly, we will square 3/7, square the numerator, square the denominator, and that's as far as we can take it. I think that's enough for me for this, and what I would like for you lovely people to do is try on your own 5, 7, 9, and 10. Note there is maybe a little hint there in how I numbered them, and please continue to try out the rest of that page. All right, good luck, have fun, and use your soap. Ta-ta!